We are live. Hello, everyone.
Hola, ¿cómo está?
Hi, everyone. I'm here in KC.
I'm bilingual, in case you didn't know it.
Here we go.
Good evening, everyone. Well, good afternoon, everyone. This is Doug Tyson, and we are here at Distributed Best Practices. It is the first time we've ever done this format. Be kind. We're doing our best. And my co-hosts are Darren Clift and Bridget Matamoros. And we go ahead and advance the slide, please.
Yes.
So a standard disclaimer. Before we get started, I feel like I need to put this in. This event is not officially sponsored by College Board or ETS. The views, information, or opinions expressed during the Distributed Best Practices 2020 event are solely those of the individuals involved and do not necessarily represent those of the College Board or Educational Testing Service. Neither College Board nor ETS is responsible and does not verify for accuracy any of the information during this event. Primary purpose of this event is education and information. On to the more important stuff. Hey everyone, I'm Doug Tyson. Normally we host this live in KC. It's awkward, to be honest, for me to be talking to a screen and not 800, 900, 1,000, 1,300 of my closest friends. We want to start by giving a lot of credit. In fact, the lion's share of the credit to Bridget. Darren and I were both involved in rubric teams for this reading, and it really took a lot more effort than in the past. And so we did not have much time. And Bridget just stepped in, took care of all the behind the scenes technology, organized all the tech that you're watching right now, put the whole thing, the intro video together. So really, if you're going to thank someone, you need to thank Bridget. Bridget, do you want to introduce yourself real quick?
Sure. My pleasure. This is one of the best events at the AP reading, so I didn't want to let this go without having something amazing. So glad everybody could be here.
Awesome. Well, let's go ahead then and introduce Darren Clift. For those of you who know Darren, he is a huge, incredible Hulk fan, and we'll let Darren speak a little bit more about that. Darren?
Good morning, everybody. It is 11 o'clock Central Daylight Time for me. So yes, sir. Welcome again, Bridget, the lion's share of all the work. We were just swamped, Doug and I, this week, and Bridget has just gone above and beyond to make sure this is put together. I'm in the Hulk office right now, the Hulk cave at home, just trying to do my usual. I've got the Hulk smash ready to go.
Hulk smash! Hulk smash!
So make sure you don't go over 5 minutes. It'll make me angry. Thanks, Doug.
Awesome. I'm officially your host. And yeah, if you're not familiar with best practices, Darren is usually the timekeeper, and we maintain a strict 5-minute time limit. And if you go over that, you'll hear from the Hulk, and Darren and the Hulk will not be happy. So real briefly, before we get into our speakers, about distributed or best practices. As I said, there are only 5-minute presentations. That's the format. You will perhaps, after seeing these, feel inadequate. I can assure you that every year I feel inadequate because I see 13, 15, 17 great ideas. And I think, why am I not doing all these amazing things in my classroom? Take heart. Just take the ideas you like and improve your craft. You don't have to take them all. You can't take them all. But take one and make yourself and your classroom even better.
Absolutely. And if this is your first time at one of these, This will be posted. The others are posted as well. So don't feel like you've got to take notes and run real fast and make sure you're getting it all right now. It'll be available online later. The other years are available online as well. You can go back and research these. We do that all the time, Doug, Bridget, and myself, and find all kinds of stuff that we love to use in our classrooms. And I'm sure today you're going to get some good stuff too.
Yeah, for sure. Now, particularly about the lineup that we have right now, 3 of our presenters are Acorns. This is their first ever AP Stats reading, and what a testament that they're willing to share some great ideas that they have. We also have 10 Acorn presenters, and by that, what I mean is we have 10 folks who are going to share some ideas with you who have never presented at best practices before. They may have been at the reading, but they have not been at best practices as a presenter. The number of years at the reading for these presenters varies from 1 to 12 years. So we have quite a breadth of experience at the reading. The CED units that are covered by these presentations are 1 through 7. Although several of the presenters did say that, the ideas they have can be taken to other units 8 and 9. So we have a breadth of ideas for you. You're going to see activities, instructional strategies, teacher hacks. By the way, I take credit for the typo there. It should be instructional strategies. That's my fault. Teacher hacks and more. Again, this is one of the best nights of the reading for me. In fact, maybe the best, because I get to hear from other real teachers about what they're doing and how it helps them in their classroom. Can we go ahead and advance to the next slide? About decorum. So this is the last thing that I'm going to say before we start rolling out our presenters, at least the intro part. There's an old saying that I heard once, maybe it's not old. If you need me to talk for an hour, I could do it right now. If you need me to talk for 5 minutes, I'm going to need a month. And what that means is if you've never tried to put together a 5-minute presentation before, it is incredibly difficult, harder than I think you may imagine. So please, if you meet these presenters out in the real world, please be kind. They've worked really hard to do this. They're taking a step out and sharing what they do. And we should honor that in great ways. This program does represent what I love most about AP Stats the most is just people's willingness to share, right? Hey, here's what I do. If it can help you, take it and do with it as you will. So let's roll out our first presenter, Stacy Elliott. Stacy's been at the reading for 5 years, and she actually shared speed dating, which is a super popular idea at the 2016 best practices. And one other quick fun fact, she recorded her video at least a dozen times to meet the 5-minute time limit because she did not want to make the Hulk angry. Stacy, take it away.
Hey, Doug, before we get started, Bridget, would you like to mention maybe a little bit about our live chat going on as well?
Oh, yeah.
Absolutely. So feel free to be participating in the live chat that you'll find on the right-hand side of your screen. And you can do some live memeing there if you want, and have fun and be respectful.
And now, Stacy, take it away.
Hi everyone, my name is Stacy Elliott, and I'm going to share with you an activity I use in my classrooms to create meaningful and engaging class discussions that are centered around multiple choice questions. A little background, a few years ago, I had a very small and a very introverted AP statistics class. Getting them to talk to me and to talk to each other about statistics was very challenging. So I started using this activity that year, and I have been using it ever since because it works really well to get students to work together and to talk about statistics in a very meaningful way. It does not require a lot. All you need is a set of multiple choice questions typed up on a sheet of paper. And I do this activity many times during the year. I do it at least once every chapter. So the way the activity works is that when students come into class, there is a set of multiple choice questions waiting for them on their desk, and they know they have about 5 or 10 minutes to start working on those problems. They often work together, which is fine, but after about 10 minutes, I then select a student at random using the popsicle sticks in my class to come up and present their answers and then lead a class discussion. My job as a teacher is now over. I sit at the back of the room at my desk and I listen to their conversations and their debates. But as a class, they are working together to come up with the correct answers to all of the questions on that multiple choice set. Now, the student that comes up initially, they put up their initial answers. Even if they didn't know the answer and they had to guess, that's fine. They just put up a set of answers to the questions. And then as a class, they go through question by question and agree on a final answer to each question. And the student that's been randomly selected is just there to call on students, maybe answer questions if they feel confident enough, to call on other students to help answer questions if they're not as sure in how to explain something. But they're working together as a class because if, in the end, the answers to all of the questions on the multiple choice set are correct, the class gets a prize. So you can imagine they are working together very diligently to make sure that they get all the questions correct. Now, the first couple of years that I did this, the prize was points added on to their next assessment, which was certainly fine. But this year, to add a little more suspense and to get them a little more on the edge of their seat, I decided that they had to roll a die. So once it is established that they got all of their answers correct as a class, that randomly selected student then would roll a die. And based on the number that it landed on would determine their prize. And you can imagine a couple of times this year that it did land on a 1. The class noise level certainly increased with the number of cheers interrupting the classes nearby for sure. As you can see, this activity is not very groundbreaking or revolutionary, but it is one of my favorite activities that I use, and my students really enjoy it as well. At the end of the year, when we were talking about the school year, the students definitely mentioned that they enjoyed doing the multiple choice sets, not just because there was a prize involved, but they really did value what they would learn in those multiple choice sets. It was only 4 to 6 problems, but the discussions they would have would be so meaningful and powerful. As we all know, students learn a lot more from their peers than they do from their teachers standing in front of the room a lot of the time. And so they would really learn from each other in a very, very meaningful way. They bonded as a class because they were working towards that common goal. And this year, there was one set that they did not get a prize because they missed one question. And trust me, they remember that fertilizer problem that they missed. They had debated it at length, and then they ended up missing it. I don't think they'll ever forget that fertilizer problem. Now, I do type up these questions on a sheet of paper. I get the majority of my questions from our class textbook, which is the 5th edition of the Practice of Statistics. But I do not have the students read the questions from the textbook because the answers are in the back of the book, and that would ruin the whole point of the activity. And the students have never figured out that that's where I'm getting the problems from anyways. But I do type them up on a sheet of paper because these multiple choice sets, and I do a total of 21 throughout the year, they become a review booklet for them at the end of the year. And I got this idea from June Bailey. I hope I pronounced that correctly. She presented in 2016 at Best Practices about students making their own review booklet from sets of multiple choice questions. So I use these multiple choice sets to create that booklet. I encourage you to look into that presentation from June if you're interested. All right, that's it. If you have any questions, feel free to reach out, and thank you for watching.
Thank you, Stacy. And our next presenter is Dave Ellinger from Seattle Prep. Dave never got the nerve up to ask a girl to dance in high school. And so thank goodness for the therapy of AP Stats to help him envision how his life could be different. Take it away, Dave.
Hi, this is Dave Ellinger from Seattle Prep, and 5 minutes is not a lot of time, so we're just going to go for it. Here we go. So this is a project that it started as just an in-class activity, and then it's going to expand to more of a project next year. And I'm doing this mostly, I thought it was kind of a fun one, and to be honest, I was going to present this at Best Practices because I thought it would be funny and it would get a lot of laughs, and so that was kind of my intention. But we're going to go for it anyway. So what it is students get a chance chance to investigate some aspect of their life and discuss it using hypothesis test theory. I use that as a blanket term for hypotheses, power, errors, alpha, all those theoretical things, and separate that from the practice. So we're going to go through an example using my life, and then the goal is to help them clarify definitions and concepts of hypothesis test theory, and then to help them remember them by hooking them to a real life situation. So what we first do is they have an assignment where they just learn the terms, and then the next day in class, they work in groups on applying those terms to this situation. The situation is that I'm going to ask Margaret Yang to prom. I'm very reticent because I don't ask people to dances. So, and there's no way because of fear, and so that she's going to say no. And so I need enough evidence to ask her. And so my friends say, "Go, you should do it. You should do it." And so I'm like, okay, I'll talk to her, and if I get a really good feeling about it, then I'll ask her. But otherwise, I'm not going to ask her. Okay? And so we can go through what the null and alternative hypotheses are, and they can go over the definition in groups and discuss that, and then they can say what that would mean in the Mr. Ellinger case. And so you get the idea of this is that it's repeating definitions and clarifying definitions in their groups, and then at the same time getting a chance to apply it in this situation. That's a lot of fun. Kids like talking about the fact that Mr. Ellinger is incompetent at dating. So then we go through the four possibilities of the null being true or false, and the evidence being convincing or not. And I go through an example there, where like the null could be true and the evidence doesn't dispute that. What does that mean? That means in this context, that means she doesn't want to go, and Mr. Ellinger gets that sense. And so will he ask her? No. And should he? No. Good choice, Mr. Ellinger. And then they can fill these things in. And I try to make that a little light because I want them to enjoy this. I mean, I want it to be fun and have that fun, that engagement help motivate them and help energize the whole thing. So then they can go through the alpha level. What does an alpha level mean? And I really emphasize this idea that the alpha, not just as a number and as a thing you compare and all that stuff, but as a measure of how skeptical you are. If you've got a tiny alpha and I go tiny alpha, then I make a pinchy face and I say, yeah, then you're really, really suspicious. And boy, that evidence is going to have to be really good. But if you have a big alpha, then a big alpha, oh, whatever, I'll take anything, kind of thing. So anyway, so they can go through what different alphas would mean and how would that describe Mr. Ellinger if he had that alpha. And then they based on they heard, what number do you think? And students usually write, it sounds like Mr. Ellinger's alpha is about 0.00001, which is accurate for that situation. And then they go through power. The red stuff is stuff that I'm thinking of putting in. I'm not sure. I'm still deciding because I'm converting this into a digital document for next year, just thinking ahead. And so I'm trying to figure out how much stuff do I put in for them ahead of time, because I need them to really understand it and be able to do it somewhat independently. But the big payoff for me was when we got to calculating how to influence power, because then there were really good examples. And this document will be freely available, and you can pause it. And so it's how you can increase power through sample size, alpha level, and the effect size. And the one I liked the best was the effect size, because sometimes students are unclear about that. And it's just the idea that, well, if she really wants to go to the dance, then it's going to be more obvious in the conversation. And so you're going to be more likely to detect it. If she then you're probably not. I thought that was the biggest payoff for all of them. The last part of this is that what's going to change next year is that once they've done this in class and we've finished this, then they're going to do the same project for themselves. So they're going to pick some aspect of their own life, some real life application of their own, and they're going to run through all of the context and application questions that we did here for my dance situation, and do the same thing for that aspect of their lives, because I want them to have really concrete hooks that they can use, that they remember. They go, oh yeah, I totally know this thing because I remember, like I wonder this thing about my dog or whatever it is. And so I'm trying to get the kids to create their own metaphors so it has really good sticking power. And so that way they can see how all these things are interrelated, and they can remember all these concepts. That's the deal. 30 seconds over. I'll take it. Bye.
Thanks, Dave. Our next presenter is Hao Nguyen Vu, and Hao Nguyen's Starbucks name, we found out, is Bob, because in Vietnamese, Bob Vu is R-rated. So with a name like Coastline College, I'm sure we're all just a little bit jealous of his job. So this is Hao Nguyen's first time presenting at Best Practices, and we are delighted to have him. Take it away, Hao Nguyen.
Hi, I'm Hao Nguyen Vu from Coastline College in beautiful Orange County, California. I'm introducing an activity that I use to clarify a fine point about the Pearson correlation coefficient R. This activity can be done in a class taught remotely, as well as in an online class taught asynchronously. Here's a conversation that happens all the time. I'd ask, if R is almost 1 or -1, what does that mean? Students would say, it means there's correlation. And I insist, there's what correlation? And students say, there's linear correlation. Yay, good job. Well, unfortunately, that's wrong. And that's why I don't ask that question anymore. Here's the real meaning of R. For R, first we suppose there's linear correlation between X and Y. And then under that assumption, R gives us the strength and direction of the linear correlation. And we do a good job of also explaining the contrapositive of it. We would explain that just because R is close to 0 doesn't mean there's no correlation. It's just that there's no linear correlation. There may be some other form of correlation. But we're still doing a pretty bad job explaining the definition itself. R only measures strength and direction of some supposed linear correlation. If we take away linear correlation, there's nothing for R to measure the strength and direction of, and it's useless. And that was what the English statistician Francis Anscombe showed when he created Anscombe's quartet. 4 scatter plots, all obviously not linear, but they have the same X bar, Y bar, SX, SY, or approximately 0.8, or squared the regression line. But our books fail to reflect that. I haven't looked at all the books, obviously, but every book that I have looked at, the examples with high absolute values of R always show a linear correlation. So the activity I'm presenting today fills in that gap. I use this website. It's a free site that you can draw a scatter plot and it will compute R for you. I let the students play with it a bit. They get a feel for R, and they see that a scatter plot that looks like a line will have R near 1 or -1. I do the usual contrapositive. Draw me something with R almost 0, but there's a nonlinear or curvilinear correlation. And sooner or later, someone draws a circle. Then I drop the other shoe. Here it goes. Draw me something that's obviously not a linear relationship, but R is at least 0.75. It takes a while, but sooner or later, someone comes up with a wavy pattern. Good job, get a prize. And then I just move on and ask for R greater than 0.9. And even 0.99. So what does that mean? It means, as Anscombe himself said, you must always look at the scatter plot and not just rely on the computed value of R. There are things on a data set that you cannot get off of the summarized statistics without looking at the graph, such as outliers, nonlinear correlation. The side benefit of this is as students play around and try to hit particular R values, they learned that R is very sensitive to small changes in individual dots. That's very nice for introducing influential points later on. That's my 5 minutes.
Thank you, Hao-Yin. Our next presenter today, I want to keep wanting to say this evening, and that's obviously not correct. Our next presenter today is actually a duo, a dynamic duo, Shelley Temple and Julie Kindred. We have often remarked that at the AP Stat Reading, sometimes we make friendships that last for life. The interesting thing about Shelley and Julie is they actually met via Twitter before the reading, but cemented their friendship at the reading. And so that's a little bit different than we normally expect. Over the years, with thousands of miles between them, they've used technology to share lessons and act as a sounding board for one another. But then COVID-19 happened. And you're going to hear what they have to share here in just a second. I'm going to say one last thing. Julie says that she is a lifelong learner who's always looking to improve her game. And Shelley would like to remind you that when you meet her, try to remember not to say Shirley Temple. She gets that a lot. Shelley and Julie, take it away.
Hi, I'm Shelley Temple, and I teach at Jenks High School in Jenks, Oklahoma.
And I'm Julie Kindred. I teach at Howland High School in Howland, Michigan.
And today we're going to talk to you about distance learning with Desmos. So Julie and I actually met years ago on Twitter, and we've used each other as bouncing ideas and how to teach various topics. But then COVID-19 happened, and we needed to help each other in figuring out how to teach our classes.
And it turns out that Desmos was the perfect solution. Desmos is really versatile.
We were actually able to use it in a way that we were able to share, where Julie's students saw my presentations and my students saw hers.
That really worked well. It's sort of the divide and conquer.
We chose this platform for a lot of reasons. It was very flexible. It allowed for a variety of different question types. It allowed for ongoing student communication, self-checking. Really let us have our typical classroom online.
What I really liked about it, there's many ways that we could have done the reaching our kids, Google Documents, Google Classroom, and we used some of that. But we really felt that there was some great engagement with some creativity by putting in media and providing questions and feedback for our kids.
For example, we had things like daily check-ins or an ability to do a class temperature check just to see how our students were doing while they were learning from home.
There's a variety of different question types. If you look at the bottom left, there's a free response question. And if you're using the sketch background, it's really great. The kids can show their learning. And you can see that there's a question that they actually have to put in an answer. On the right-hand side, it kind of looks like it's a multiple choice question, but it's not. There's a video that was embedded, and the students would watch a video, and then they have it, you can see it maybe, it says select all that apply. So it looks like it was something that was probably a inference procedure. They had to figure out it was means and proportions, one sample or two sample.
One of the best features that's fairly new to Desmos is the idea of student and teacher feedback. So it really allowed for an ongoing conversation. In this example, you'll notice a student response about describing this distribution. And a lot of students actually thought these were two separate distributions versus the same data set. And so with that teacher feedback, we were actually able to communicate with our students and clarify any misconceptions.
That's awesome, Shelley. You also have self-evaluation in Desmos. There's a table on the left-hand side where the kids would fill it out, and you get immediate feedback when they check their work. And a really cool thing I saw just recently is a teacher added another column and actually put a link to a video showing kids how to solve the problem. And on the other side, you see a card sort that will give immediate results to the kids and their feedback.
Now, both of these examples with the self-checking does require a little bit of extra programming called the computational layer, which Julie and I both learned a lot about during our distance learning journey.
Yeah, no worries. There's a lot of copying and pasting on some really brilliant computational layer learners.
When you're looking at things like multiple choice questions, you can either set it up using computational layer, like over here on the left, where students can self-check. You could add links. So in this situation, you'll notice that it adds a situation for them to watch a short video and then provide feedback. But on the teacher side as well, you can also see how students responded to a question and be able to see who you maybe need to redirect.
Here's another look at multiple choice questions. You can check them after after you've solved a few. The kids can solve a few and check their results, or you can give immediate feedback for each question at a time.
So really, what did the students have to say about this? And honestly, a lot of them really enjoyed having the self-checking, having the self-paced activities, but really having the teacher interaction. They really appreciated being able to talk to us.
Yeah, sometimes you get some feedback that maybe you didn't want to see. That was my bad video link, but it was nice to be able to feel connected to the kids during this time.
So we really appreciate your time today, and we would love to hear from you. If you have any questions, please contact us either on email or Twitter, and here's a link to our favorite activities.
Thank you, everyone.
Thank you so much, Shelley, not Shirley, and Julie. We really appreciate your ideas. And our next presenter is Keisha Brown. Fun fact, Keisha is an Acorn presenter and a presenter who's an Acorn. This is her first AP reading, and she has graciously shared, offered to share her ideas with us. Keisha is going to be sharing StatCrunch with us, and that's becoming increasingly important, having the technology skills and wherewithal during this quarantine time. Take it away, Keisha.
Welcome to StatCrunch to the Rescue. My name is Keisha Brown, and I teach at Georgia State University. In this video, I would like to talk about what is StatCrunch and the top 3 features that I love about this software. StatCrunch is Pearson's web-based statistical analysis software, and you have access to the software either if you use their textbook or you can get it individually as well. My number 3 favorite feature about StatCrunch are the graphing capabilities. At the beginning of the pandemic, I acquired this data set that listed by each state how many cases had been identified. And in class, we were able to quickly see this, and we have various different graphs. We can create a pie chart of this information. And we're able to quickly see all of the states and their frequency and relative frequency distributions. We can also create a graph that I saw in the news. So by state, you were able to see the number of cases, and you had different color representations. So we were able to quickly create the same thing that our students had seen in an article online, which empowered them to want to learn more and do more analysis. My number 2 favorite thing about StatCrunch are the applets that are available. The correlation by eye, students are able to guess and play around with their correlation coefficient to see if they understand the principles, and they get a hint of things that they can try, and they can show the answer. They are able to do the same thing with regression and compare the answers of the correct least squares regression line and try to get their line closer. I also like the distributions demonstration when we are initially talking about normal distributions, and they can see how the mean affects their distribution and how the standard deviation also affects their distribution. My favorite applet by far are the ones about sampling distributions. And for my students, I give them a lab where they have to create 10,000 samples based on each of these different populations. And they have to describe to me what the sampling distribution of the sample mean looks like when their sample size is 2. Then they also have to compare the mean of the population with the mean of the standard deviation, our standard error. Then I have them to change the sample size on each. And then they take another 10,000 samples. And students complete this lab before we initially discuss sampling distributions. And it has given them a better idea of how these sampling distributions are created, and it helps them to relate the formulas that we talk about as well. My number one reason that I love StatCrunch is because of the calculators. With these calculators, you can enter data into the spreadsheet area. And this is from discrete probability distributions when we're talking about a life insurance policy of 1 year. We can use the custom calculator, and we can determine the expected value from the perspective of the insurance company. We also have the binomial calculator where they can enter their parameters and change the direction of their probability, and they're able to visually see with the red what is actually being calculated in each of these. And we can do the same exact thing with the normal distribution. You also have the ability to look for probabilities between two values as well. This helps those students who are visual actually understand this with a deeper level. I hope you've enjoyed this video. Have a great day.
Thank you so much, Keisha. I just wanted to point out that Keisha is one of 3 presenters from Georgia, and so Georgia is well represented here today. So let's move on to,
Hey,
Aaron?
Doug, how about we formally welcome Keisha since she went maybe 2 seconds over? What do you think?
I think that'd be a good idea.
Welcome, Keisha.
Hulk smash!
Keep it down below 5 minutes, please.
Hulk smash!
Thanks, guys.
All right. So yes, our next presenter is Riva. Riva Shoyemi is from Prosper, Texas. And one of Riva's embarrassing moments from high school was when she and some club members were at someone's house, and they went outside to socialize, and she accidentally ran into the patio glass. Well, when everybody came back in, interestingly, there was a deep red kiss mark on the glass from lipstick. And Riva thought she was going to get away scot-free when she noticed everybody chuckling because she was the only person with deep red lipstick on that day. So Riva, will you go ahead and take it away?
Around the World, Inference and Around Robin. My name is Riva Shoyemi, and I am a high school math teacher at Prosper High School in Prosper, Texas. The objective of this lesson is to give students the chance to work individually as well as collaboratively on an inference procedure under time conditions using various formats. The students will have the opportunity to work in a group of 3 to 4, or maybe working in a pair, in a round robin format that will last for 15 minutes. After the 15 minutes, the students will then proceed to discuss or debate their particular completed work, making sure that comments are made on the Post-it and the Post-its end up on the completed work. This particular lesson / activity does align with the AP Stats Units 6 through 9. The students with the prerequisite should have experience with the appropriate 4-step inference procedure. So then they should be able to identify the appropriate inference procedures in various contexts and also to apply them. The teacher will need to get together 4 to 8, maybe even 12 or 16 different worksheets, meaning each worksheet should have a different inference procedure prompt. Keeping in mind that for every group, each group in your classroom, whether there's 2, 3, or 4 students, they should have the same concept, but each person in that group should have a different problem. So that will help you somewhat in determining your number of worksheets. You'll also need a timer and Post-its, and the students will need their calculators. The timing for this activity is about 35 to 45 minutes to give you time to carry out the main steps. Please note, it is important to inform your students about a round robin, as well as in informing the students that this will be a timed activity, and you will begin by placing a worksheet on every student's desk, just making sure that it's face down. So pretty much what will take place, this gives you a nice little overview. The students will work on an inference procedure in 4 steps, where the timing will be for the introduction, moving on into naming the procedure and then writing the assumptions, then the calculations, then the conclusion. Keeping in mind that for each step, as each step ends, the students will then rotate the papers clockwise to their fellow classmate that's within the same group. This is not a race, although it is a timed activity, but you will see that some groups will finish a step a little earlier. So feel free to have them to proceed. Make sure that they have shifted the paper clockwise, but they may proceed to the next step. At the end of the 4th step, when the conclusion has occurred, the teacher can begin passing out the Post-its, and then students can begin having mini discussions within their group. You also have the option at the end, so the whole class can see everything, of doing a gallery walk by posting the papers around the classroom, or even uploading them to a Google slide in PowerPoint and having a virtual gallery walk. For the next couple of slides, you will see the timing that can be used depending upon which particular steps your students use as they're working out inference procedures. But please note that the 4 steps are pretty much like the same no matter which method that you happen to use. Here are some suggested resources if you just need to have a variety of different types of things. And then please feel free to contact me. You can send me an email and let me know also how maybe you have even changed up this lesson, because this definitely has evolved for me within the past 3 to 4 years. But note that the interaction in the classroom really, truly is priceless.
Thank you so much, Riva. Our next presenter is Tom Rothery. One fun fact about Tom: while he was a student at Arizona State, he was chosen to be on The Price is Right, and he made it all the way to the Showcase Showdown. Unfortunately, he overbid his showcase by $175, losing lots of cash and prizes. Tom, take it away.
Hi, my name is Tom Rothery. I work at Perry High School in Gilbert, Arizona, and the title of my presentation is Peanut Butter and Jelly, a Recipe for Success. And welcome to my kitchen. All right, one of my biggest challenges that I have with students, especially in the beginning of the year of an AP statistics class, is having them show complete work. Okay, whether it's a block design or having students write out a paragraph explaining their methodology, there are sometimes gaps where just details don't exist. And to help students know the value of details, I have them do an activity where they take out a sheet of paper and a pencil and write a recipe for making a peanut butter and jelly sandwich to someone who has never seen or eaten a peanut butter and jelly sandwich before. And that's why I use an example of Chewbacca, because I'm assuming he has never had one. Okay, I give students about 15 minutes to work on it, though I don't really give them a timeline. And some students will finish it in 30 seconds. That's this type of kid. And some will take a very sincere effort and finish it in 15 minutes. Now, once I'm done, what I'll do is I'll take all the papers, I'll spend a couple days looking at the ones that are maybe a little bit more vague and ones that are very complete. And then one day in class, sometime later, I will bring a jar of peanut butter, I'll bring some jelly, I'll bring a loaf of bread, and a butter knife to class, okay? And what I'm gonna do is I'm gonna put some students' set of directions underneath my overhead, and I'm going to follow it exactly. Sorry about that. Just want to make sure you can see. Okay. And whatever they write, I'm going to do those exact directions based off my interpretation. Okay. So I have all those ingredients. The first thing it says is obtain 2 pieces of bread from a loaf, separate them side up so they touch each other. Okay. No big deal. Right. Now it says spread a light amount of peanut butter evenly on both sides. Okay. So I have to get some peanut butter the way that I believe is right for someone who's never seen this before, and I'm going to spread it on both sides. Okay, now, I don't know if both sides means this side and this side over here, or maybe it actually means this side as well. I'll do both because I'm not sure. Okay, and that set of directions is done. The fourth piece says put a medium portion of raspberry jelly on one of the sides. Here's my raspberry jelly. Never seen it before. Hope it tastes good. Again, I'll take some out as it asks and put over one of the slices, okay, just as it says. Place back together so that each slice, okay, is lined up perfectly, okay? And it doesn't really say which way they should be lined up, so I will do that the way I believe is right, and I'll put it in front of me and I'll ask my students, is that the way that you expected your peanut butter sandwich, jelly sandwich to be made? And they'll say no, of course, and they'll have some laughs, but they get the idea that this set of directions, this recipe was lacking details, okay? Yes, maybe we should have used a knife. Yes, maybe we should have decided what a side is. Maybe a side is a base. Maybe it is the outside of a piece of bread. Okay, we have to be a little bit more specific. Okay, so then what I'll do is I will put up another one that is a little bit more complete. Okay, and the first part is pretty much what we had before. The second piece, okay, says use the knife to spread the peanut butter on one piece of the bread, and that's great because we didn't have that last time. Okay, so when I use my knife, okay, it's open to my interpretation in terms of what that means. Okay, so since they didn't have specifics, I will use the butt end of the knife and I will spread it on my bread. Okay. And then further it says, clean off the knife. And I get that because you don't want to take your peanut butter knife and stick it in the jelly. So we will clean this off. And I guess I'll just do it any way I want because it doesn't say how to do that. And it's now clean for me to use with my jelly. Okay, and I can go through and I can finish it. And at this point, students get the idea that details are imperative, okay? Whether it's a peanut butter and jelly sandwich or doing your AP exam, oh, 1 minute, or your research, okay? You have to include your details, okay? Otherwise it's not complete, and it's up to the, I'll say, the audience's mercy to decide what they believe is truthful if you have gaps, okay? So being complete is so important, okay? Again, there will be a student actually who does one perfect, okay? And I always put that underneath the overhead just to get that perfect explanation of how a recipe should be done. I usually don't make the sandwich just because it's just not as fun, okay? Again, students get it. And I'll say that after I do this activity, I don't have to fight kids as much in terms of writing paragraphs, in terms of making sure there's specific details, okay? Whether it's writing a simulation or if it's for inference, where we know there's a lot of parts of written work, they know what the expectations are in terms of being complete, okay? Here's my email address, a couple of them. Again, I work at Perry High School in Gilbert, Arizona. Feel free to contact me. I hope someone gives this a try because I would love to share a laugh with you and let me know how it went. And if you have any questions, feel free to let me know. All right, hope to see you next year in Kansas City. We got peanut butter all over my fingers. I gotta shut this off, which I can't do.
Thank you, Tom. Tom, we are sad that you didn't get your Showcase Showdown, that you didn't win the big prize, but we are thankful that you shared your ideas with us. Our next presenter, Darren?
That was great. That was great. I will remember that. I know the kids will too. How are you not laughing, Doug? That was awesome.
I'm trying to keep composed here. I'm supposed to be the host, so there's a decorum that's expected. You're
My
not
bad.
helping.
Just mute me then and keep going.
I was just a little bit disappointed that the Hulk didn't make an appearance. I mean, he did go over.
I love it.
He went over 5 minutes, but if he makes you laugh enough, does that mean it's okay?
Yeah, it's okay.
Okay.
It's okay.
Okay.
Great job. Great job.
Putting the hand in the peanut butter jar. That was pretty good. I'll give it to you. All right, now I'll try and regain my composure. Okay. Danielle is our next presenter, Danielle Maletta, and she's from Eastside Catholic High School, all the way from Sammamish, Washington. Yes, that's right, a town named Sammamish. I couldn't believe it either. Danielle is also an Acorn presenter. Now, she is not an Acorn. She has been at the reading before, but she's an Acorn presenter. And although she's only been a reader for 2 years, we loved her presentation. Danielle, thanks so much. Take it away.
Hey everyone, my name is Danielle Maletta. I teach math and computer science at Eastside Catholic High School in the good old Washington State in Sammamish. This is my email right here in case anything I show you want physical copies of. I'm more than happy to share. I don't have any like cool activities for you today, so no like stomp rockets or Starburst or Hershey's Kisses or anything, but I'm going to show you basically what students have told me over the years is the top thing that they find useful in the class in terms of preparing for exams and also leading up to the AP exam. So at the end of each unit, we complete a unit summary together, and then they use that as a reference while they're doing review problems, and then they later review it for things like midterms and projects. And this year, with the open note exam, they were able to use it on the test, so that was kind of nice. So I've even had students contact me after going away to college and taking a stats class and saying, oh my God, I love that I still had my unit summaries because that made such a difference. So it's just one of those things that's nice to kind of put everything. I try to get it on one page as much as possible, but it doesn't always work out that way. So I just kind of want to give you an idea of what it looks like. And then I filled one in. I had to put everything in one place here, so these aren't filled in, but I can also give you filled in copies. So it's broken down by each unit from College Board. So, and then they're each kind of these little charts that organize ideas and key concepts from the chapter, with the exception of one that you'll see that looks like madness, but the students enjoy it. So obviously the one variable data, we kind of just go through, fill this little thing out with examples and some definitions sometimes. There's little hints, like over here, always use context. And then this is the one sort of bizarre one, but this is when we're looking at data and kind of you'd have the big idea of data and then you break it down, looking at the distribution and the density curve, and is it normal or is it not normal, and what do we do with it? So it works nice with kind of a flow chart. And then, so 2 variable data with scatter plots, observation studies, experiments. So you can kind of see like there's one for every single unit. The probability unit, thanks to the new release, is beefy. So we have all of your, Venn diagram, two-way table, all that good stuff. And then discrete and continuous random variables, and then binomial and geometric. So that one's a little long. Then of course, sampling distributions. And the nice thing is a lot of these, as we start going through, either break up into nice, neat columns. This one in sampling distributions says proportions and means, but later on down here, then we get confidence intervals and hypothesis test. Okay, so here's one filled out just to kind of give you an idea. And so at the end of this unit, the class kind of gets this out together and we work through it. So, first things first, what's the parameter of interest? What does that mean? What does it look like? And then sometimes, especially like this is the first chapter or unit where you're doing p-values and confidence intervals, and so some definition stuff is important, so it has that on there. And we just try and sum it up as simple as possible so that it's in a nice bite-sized piece and it's somewhere they can go and find it really easily. And then I use TPS, so we have the state plan do conclude. And so that's how all of these are set up. So you can see it has the confidence interval and then hypothesis test, and then it runs through the state plan do conclude for each of those. And then we have the error types, and then you would go on to two proportions and go through the same thing. So that is pretty much it. Nothing terribly complicated, but I just thought, hey, you know, best teachers, we all just beg, borrow, and steal. So why not share something that some people could find useful? So if you think that would be useful and you would like copies of this, I'm happy to share originals so that then you can cut and paste as you need to, depending on your text and what's taught in what order. So that's all. Enjoy. Have a good one.
Danielle, beg, borrow, and steal is indeed the truth. Thank you so much for sharing, because we all do that. At least I know I do. And so our next presenter is Marvelyn Tapp, who is our second presenter from Georgia. Marvelyn once integrated the variable K with respect to Y in class. For those of you with a little calc savvy, you can imagine student reactions. Marvelyn, take it away.
I'm Marvelyn Tapp, instructor at Georgia State University, Perimeter College in Atlanta, Georgia. This presentation is Low-Tech Quickies, quickly assessing student understanding with Blackboards. I would teach what I thought was a great lecture on a specific topic. Spend time grading exams based on that topic, only to find students didn't quite understand the concept as well as I thought. I tried more thorough explanations, additional examples, more homework problems. None of that seemed to work. I started searching for an alternative idea that did not rely too much on technology, cost a lot of money, that's in short supply, or take a lot of time during class. Then it hit me, whiteboards, personalized size whiteboards for students. I ordered a classroom set of whiteboards, markers, and erasers from Amazon. These are dry erase blackboards by Dreamline Products. I used them for understanding the area under standard normal curves and the position of z-scores on the horizontal axis. I called out statements such as 2 standard deviations above the mean. Students drew a curve, marked the value, and held up their boards for me. I was able to quickly assess every student just by looking around the room. I gave a quick thumbs up or a head nod to correct answers and quickly helped others. I also tried statements such as shade an area of 5% in each tail. Again, students drew on their boards, shaded, and held them up for me to see. Here's what they look like. As we did more problems, they got better and better. Proud of them. Look at all these great graphs. Lots of participation. Some positives. Really enthusiastic student engagement and positive feedback. Great peer collaboration between students. Exam score averages increased 17 to 22%. And exam score median jumped by 41%. They had a better understanding of subsequent topics. It was a brief time commitment in class, about 10 or 15 minutes, and zero prep. All I did was bring the boards to class. Some additional ideas where this could be used: demonstrating the empirical rule, illustrate skewness, visually represent changes in standard deviation, understand strength and direction of scatter plots. And I'm sure there's more, but overall, this was a low-cost, quick, and effective idea to increase student understanding. Hopefully some inspiration is blooming. Thank you. And here's my contact information again.
Marvelin, low cost, low time, high impact. That checks all the boxes. Thank you so much for sharing your idea. Next up is Brian Broderick. Brian is going to share with us an exit poll idea. And in fact, Brian lives on the edge because his exit poll almost got one of his students arrested. This is true. I'm not making this up. It is a long story, but let's just say Brian Broderick's class 1, grumpy poll workers 0. Brian, you also get high marks for facial hair. Take it away, Brian.
All right, AP Stat colleagues. Hello, my name is Brian Broderick. I'm an AP Stat teacher at U.S. Grant High School in South Oklahoma City, and I'm here to share my exit poll project. This is a project that is a lot of fun. It's a great interdisciplinary opportunity, and it's one of the most memorable experiences that my kids have in AP Stat. Now, I really only do it every other year when there's a presidential or midterm election. It's really tough to make this work well if it's a smaller election, but when it does work, it is a great experience. I want to share with you how I make it work. So the first thing I do is teach my kids what an exit poll is. Basically, you're just getting people coming out of the polling place and asking them how they voted on certain issues and getting some demographic information. And we talk about why this is so important, why media companies want this, and why just the general public finds interest in it. You know, people want to know how the election go, how do different subgroups feel about different issues. And so these exit polls will address that. And so kids are collecting a real live exit poll on election day in this project. And so the first thing we do to do this is figure out, well, how are we going to get our data? So we look at the different sampling techniques we've discussed all throughout the semester, and kids analyze, okay, well, how would this look in an exit poll context? How could we use each of these to select people coming out of a polling site? And then we come back together as a class, discuss the pros and cons, and we basically decide which one works best. Or should we use a multi-stage? Should we combine maybe some elements of one or two of these? And so what I found is that the systematic sample usually tends to work the best. Definitely the most efficient method. That's the one we've used in the past. But again, give your kids ownership of this. Let them decide which one is going to work best because they're the ones who are going to be actually doing this. Once you've done that, once you know how to collect the data, then we're going to figure out the logistics. And so to do this, I break kids up in committees. First committee is question committee. So what questions are we going to ask? What are we going to prioritize? How are we going to keep this, short and sweet? We've got the public relations committee. So they determine how we're going to ask these questions. Maybe giving a script that kids can use, talking about etiquette, talking about what to do if someone says no, and how to be polite and respectful no matter what. A logistics committee, looking up where the polling places are, how to get there, what hours they're open, those sorts of details that we need to know. Rules and Regulations Committee. Now, of course, you need to be aware of these yourself ahead of time to make sure that this is airtight. But again, giving kids ownership, making sure they're looking up the rules as well. Local, state, federal laws, what laws are out there concerning exit polls? What do we have to be aware of to make sure that this exit poll is actually going to be sanctioned? And then if you have enough kids in your class to make another committee, I like doing a problem-solving committee. Get your critical thinkers together to think about, okay, what issues could come up, what can we maybe do about it? Again, the more prior planning you can do, the more smoothly this will go on election day, especially if you're doing this for the first time. So here is an example of an exit poll survey we did one year. Again, you can see very short and sweet, just a couple demographic pieces of info, some real quick questions. Some kids like to ask these questions verbally. Some kids will just print these out on a slip and hand them to a voter and be like, hey, can you fill this out for us real quick? Whichever one works best, both work totally fine, just as long as we get the data. So on election day itself, I have kids sign up for 1-hour shifts. You can get kids from other classes. You can even ask some of your colleagues in history and government to maybe give extra credit to kids to do this. That way you get as many kids as possible to do this. You want multiple kids per shift. 2 or 3 is what I recommend. You don't want kids by themselves for obvious reasons. But if you have like 4 or 5 or 6, it starts looking like a flock of vultures around these poor people coming out of the polling place. So 2 or 3 I've found is, a pretty good number for any given shift. And the nice thing is that not every kid has to be a pollster. Not every kid is comfortable talking face to face, and that's okay. Some kids are. You see some pictures here, some kids who are actually, on the ground getting the data from people. But then these kids will collect that data and they'll give it to kids stationed either in the school or at a local restaurant with Wi-Fi or some sort of home base, so to speak, to input that data in a spreadsheet so that we can analyze it. And in second semester, that's exactly what we do. We take this data, we use confidence intervals and significance tests to see, hey, did our sample represent the population? We'll have our parameter. Obviously, after election night, you'll know the percentage of state and percent of the nation and even of the individual precincts that got the data, and we can use that to analyze what that says about our survey, how well we did, how well we were able to predict the actual result. So that is all I've got, folks. There's my contact info given. I hope you really enjoyed this. Let me know if you need anything else. Thank you all so much.
Thank you so much, Brian. Almost getting your student arrested, that's an amazing activity. I mean, I'm intrigued. Josh Wilkerson is our next presenter. He comes to us from the Regents School of Austin. The last and only reading that Josh attended was in 2014, and he spoke at Best Practices Night, and I distinctly remember his presentation. He is going to talk to us about service learning, and he had only been doing it for 3 years, but now he's been doing it for 9 years, has written a dissertation on the subject, and has worked with AP to promote service learning in their curriculum. So with no further ado, Josh, take it away.
Hi, my name is Josh Wilkerson, and I teach at Regents School of Austin in Austin, Texas. And I want to take the next few minutes to talk to you about something near and dear to my heart, and that is using service learning in the context of AP statistics. Now, with these talks only being about 5 minutes, there is no way that I can go into all the ins and outs and little details of how to implement a service project in your course, but I can point you to a lot of resources. You see my email on the screen here. I'm always happy to connect with anyone who's interested. My hope in this talk is really just to talk about the motivation behind doing a service learning project. And if I can sell you on that, then at least we've started a conversation. So I want to start by looking at what I consider the main question of every math classroom, and you probably already know what it is by seeing the slide. I know a lot of us teach statistics, but then we probably also teach other math courses. And not that we have this question all that often in statistics, but certainly in other math courses, the main question from students is typically, when am I ever going to use this, right? Now, while we don't get that in statistics because we're dealing so much with application, I think to consider ourselves good in that sense is a mistake. Because when a student in a math classroom is typically asking, when am I ever going to use this? What they don't really want a time frame answer. That's not really what they're looking for, right? They're really making a statement when they make a question like this, like, when am I ever going to use this? So what they're really asking, I believe, is they're asking, why should I value this? And so if we feel like all we're doing is addressing application, and so we're good on this front, then we're missing out on an opportunity as educators in a statistics classroom, that our students are still seeking to find value in what they're learning. We'll often use significance in stats, like as a quantitative measurement of significance. But in everyday language, right, that word has so much more meaning at a more effective level that I think we need to be mindful of. And so one thing that I really like about service learning is this effective level of development in the student is really the primary objective, that they're using what they learn in the context of their course and they're applying it in a situation that's serving their community, right? So they're doing it in a service context. They're seeing how this is actually aiding other people, but at the same time, they're having to do a pretty complex cognitive task in terms of integrating everything they've learned in the course and doing survey design, gathering data, analyzing data, presenting results. Right? They're being asked to do all of that in the context of serving their community. So my hope is that we can turn, students from having this type of posture toward mathematics to having more of this type of posture toward mathematics. So this is one example of what my students have done in the past, where we partner with a local organization who provides affordable housing for the formerly homeless. And we develop a survey for them, we go out and administer it, and then run the data and then present the results back to them. And the students really get a chance to not just know the numbers, but know the people behind the numbers. I really want students to understand in a statistics class that behind every piece of data is a person, and that person has a story, and their story matters. And service learning really opens the door to have those conversations in the context of a math classroom. So I have a few numbers here to throw at you, statisticians. This is just from one survey from one class I did. I've done this every year for the past 7 or 8 years. And so I can give you more details on more numbers behind these particular questions that tend to back this up. But just to show you some of the feedback. So you can see how the subject matter is used in everyday life, understanding course content, enhancing learning. But what I really want to get to are these slides. Made me more aware of my own biases and prejudices. Gave me a deeper appreciation for the course content, right? And so if that's something that you're aiming for in your statistics class, then I encourage you to check out Teaching AP with We Service, which is all about equipping AP educators across all disciplines to implement service learning projects in their courses. I also encourage you to check out a website I started called slmath.com that's got a lot of examples and resources from the projects that.
Hey, Josh, you're killing me, Smalls.
Hulk smash! Hulk smash!
That's your 5-minute warning. Don't make me angry. Back to it, Bridget.
And resources from the projects that I've done in the past. And while this is by no means robust, again, I hope it just starts a conversation. So thank you for your time, and I hope you enjoy this distributed reading.
Josh, congratulations on successfully evading the Hulk, and also for making me feel like I'm an inadequate educator. That is an amazing, amazing idea, bringing out the best in what education could be. Darren?
Good job, Josh. Loved it. Yeah, love the idea. And we've got some of their suggesting that you get with your AP government teacher as well. That's fantastic ideas, fellas. Appreciate you commenting on the live chat.
Bridget?
I also wanted to mention that this past year, I had been looking for ways to get into the whole AP with We, and so this presentation was perfect for me to learn kind of the best entry point. So thank you for that, Josh.
All right. So following Josh, our next presenter is Lee Natero. And Lee shared a funny story with us. About 20 years ago, Lee was at a high school in Vermont and volunteered to be on the math department rep to the tech committee. And so she went to her committee meeting, her first meeting. They asked if she knew Max, and she replied that no, she didn't. Interestingly, she never understood why they never introduced her to her colleague named Max. Of course, we all know that it was the Mac computer, and she this semester, this fall, she will actually be teaching online synchronous classes on, guess what? Her MacBook Pro. Lee, take it away.
Hello, I'm Lee Natero, and I'm going to be talking to you about building statistical communication with the New York Times What's Going On in This Graph. Please feel free to reach out to me with any questions you may have through my email or through Twitter. As we know, communication in statistics is a key component of statistical understanding, and we need to help our students learn how to describe data presented numerically or graphically. But how can we do this when our students are not very good at communicating mathematically to begin with? One of the things that I have found to be very helpful, especially for students that aren't used to communicating mathematically, is to use the New York Times feature, What's Going On in This Graph. This is a feature that's been around for about 3 years now as a collaboration between the New York Times and the American Statistical Association. It's free, it happens weekly, and it's moderated on Wednesdays. The way it works is that a graph is posted that came from a New York Times article. Students are asked to take a look at the graph, and they're asked what do they notice about the graph and what do they wonder about it, and they're encouraged to write a catchy headline. Next year, students will be asked to consider the impact of the data on themselves and their communities. The graphs are varied and come from topics such as sports, history, culture, health, and science. Students can post their observations and comments, and they're moderated live on Wednesdays from 9 a.m. to 2 p.m. Eastern Time. On Thursday, the article is revealed that the graph came from, along with comments about students' observations and related statistical concepts. Here's an example of one of the graphs that appeared in what's going on in this graph. I would encourage you to pause the video so that you can think about what's going on in the graph. What do you notice about it? What do you wonder about it? So what are some ways you can use what's going on in this graph in your classroom? One of the things you can do is to get students to notice and wonder about the graph and communicate their thoughts verbally. You might think of this as a simple turn and talk. However, I'd ask that you use a stand and talk that was invented by Sarah Vanderwerf. If you're not familiar with what this teaching technique is, I encourage you to Google it. Basically, it's like a stand and turn and talk, but better. Students actually stand up and go to talk to somebody else in the room about the graph after they'd had a chance to think about it themselves. This will give you an opportunity to have all your students talking about math in your class every day. A second thing you could do to use what's going on in this graph is to create a single class comment based on synthesizing student observations. If you want to see how this can be done, I would encourage you to Google Teach 180 what's going on in this graph, and it will take you to a blog entry that describes how I did this in my classroom. A third way you can use what's going on in this graph is to have students actually post individually and encourage them to post a response to other comments that have been posted. If you're going to be doing remote teaching in the fall, you could ask students to notice and wonder for a specific graph that they see on their screens. However, instead of typing in the chat and hitting enter, tell them to wait until you give them the signal to hit enter. And then when you say enter, there'll be a chat explosion on your screen. This allows students that are a little bit slower in typing or slower in thinking to have a chance to put their thoughts down in writing. And the final way you can use what's going on in this graph is within a Desmos Activity Builder lesson. Desmos created several Activity Builder lessons around what's going on in this graph. Students get to notice from the graph, wonder from the graph, create that catchy headline, and then it encourages them to look at what other students might have said about the graph. If you're familiar with Desmos and Desmos Activity Builder and want to use Desmos Activity Builder lessons with what's going on in this graph, I would encourage you to grab that top hyperlink there and bookmark it. If you want to create your own what's going on in this graph Desmos Activity Builder lessons yourself, I would encourage you to grab that second bit.ly so that you can do that yourself. If you want to learn more about what's going on in this graph, I would encourage you to use the hyperlink that you see here. There you will also find a link to a webinar recording for a webinar that happened earlier in the month of June. If you have any questions, please feel free to reach out to me. This is Lee Natero talking about building statistical communication with the New York Times, what's going on in this graph.
Lee, you came that close. That 2 seconds, Lee. Good job.
All right, everyone. We have just 2 presenters left by my count. I hope I didn't count wrong. I'm going to double check my count. Nope, we have 3 presenters left. So I did count wrong. Time to take my math degrees away. Our next presenter is Jamie Henk. And Jamie comes to us from Georgia, our 3rd presenter from Georgia. Georgia is the most frequent state among our presenters this year. And Jamie revealed to us that when he first tried this activity in his classroom, he had some unannounced visitors come to observe his class. Not being sure exactly what to do, he had them just join in. Now, the interesting part is that Jamie happened to be on the floor at the time because the activity involved measuring feet. So Jamie was literally crawling around his classroom, measuring feet when these visitors came in and he said, "You're next. We're going to measure your feet." Turns out those visitors were bigwigs from his county district. The good news is they participated, had some fun, and it worked out pretty well for Jamie. Jamie, take it away.
So I use the proportional activity as we're working with regression after we go over some of the basics with it. And we use, are you proportional with the parts of the body? So to start with, we look at this bit of information. This is parts of the body that are proportional, and the kids get a good laugh out of some of them. Usually the two that I will use in class is the length of the foot is equal to the length of the forearm, and the neck to wrist ratio is 1:2. Now, I prefer not to do the neck always in class because I'm scared one of the kids will do something with the measuring tape around their neck, squeeze too hard, do something really weird. But that one works well, as does the length of the foot and the length of the forearm. For the sakes of this, we'll use the length of the foot versus the length of the forearm. So I remind my kids before we do this to please wear socks. I hate bare feet walking around on my floor. The first thing we ask them to do is to measure their foot length on a sheet of paper. So they'll put their foot down on a sheet of paper. Most of them can get by with an 8.5 by 11. Sometimes I have to pull out the 11 by 14. They'll turn their foot a little sideways. They put a mark down on the paper at the top of their foot, and someone will mark where their heel is, and they'll do it with both feet. That'll give them their measurements. It is obviously easier if they have someone near them to help them do this. So I try to pair my students up so they have someone to help them mark their feet or measure them. In class, we have multiple ways. We have tape measures, which work very well, rulers, yardsticks. I try to make it easy for the kids. If at all possible, we have to use centimeters because they can figure out a tenth, and they have multiple issues with it when they are working with inches and trying to figure out if it's an eighth or a quarter. If we do this at home, we would use tape measures. Most of the kids had one of those or a ruler laying around. At that point, we did have to use inches, and I told the kids to do it to the nearest eighth or half or whatever they were working with. Basically, we ended up doing it to 1 decimal place after all was said and done to make our data easier to use. After all the measurements were done, they got their forearm done, we needed to collect our data and put it all together. So if we were at home, they would use a Google form, they would enter their numbers. I would clean up the data and then present it to the class so they could use it to put it in their calculators. At school, we write the data on the board just for simplicity, and then we enter the data in L1, L2. We start with using the foot in L1, and we use our arm length in L2. Once we get our data all together, the students get it in L1 and L2. We do a few things with it. We find the equation of the least square regression line. We'll identify the slope and the y-intercept and discuss it in context of what it truly means. We describe the line and the relationship between the variables, and then we discuss what happens if we switch the explanatory and the response variable. And at this point, we are able to actually switch them in our calculator, and the students can see the relationship, and they'll go through and follow those 3 steps ahead of it once again. So we know our kids work at the pace of snails when at all possible. So for my classes, this is a 90-minute block class that we do this in. What I did last year was I had the students actually do the data on one of our shorter classes. We have 1 day a week, we're 45 minutes. We did the data that day, and then we did the exploratory stuff the next day. You could also throw a loop into this, and if you do the neck and the wrist, have some people actually double their wrist length and some people not double their wrist length, so you get a little bit of differences in the regression line.
Thank you so much, Jamie. Now we're down to 2 presenters. The ever enthusiastic Laura Ringwood is next. And Laura revealed to us that while she was trying to be the cool mom in the grocery store, she took a hook shot and tried to lob a box of Jell-O over her son's head into the grocery cart. Now, she was right on target. She would have been perfectly on target, except that a nearby senior citizen realized that that box of Jell-O might have damaged that cart. And so he saved the day by putting his head in between the flying box of Jell-O and the bottom of that cart. And all is well, though. There were no injuries sustained, and the senior citizen remarked that he wished that maybe he had sent his wife to the store that day. So, without any further ado, Laura, take it away.
Yay, it's best practices night. My name is Laura Ringwood. I teach in a public high school in Austin, Texas. There's about 2,800 kids in my high school. And you've probably had the same experience as I have, where your students bring you graphs such as this one and they say, isn't this a bad graph? And they love to criticize things with their new statistical knowledge. So what I want to share with you in these few minutes is a few ideas for taking that enthusiasm and turning it into becoming more of a statistical consultant. So first, we'll talk about a few ideas that you can sprinkle into an AP Stats course, or if you'd really like to expound and expand them, you can create a whole second year course. So here we go. One of the first things that we did as statistical consultants is partner with our school newspaper. The school newspaper used to just email blast the whole student body whenever they wanted to do a survey. And of course, my students would criticize that a little bit. And so we would talk about other ways that maybe we could support the school newspaper instead of just criticizing them. And so we started running a simple random sample of the student body for the school newspaper. They were very excited to have us do that work for them. And on the screen here, you can see several of the questions that we've asked. Actually, this was just from the spring. And so we do random sample the students. We invite them to come to our classroom during lunch and take the survey. If you really want to get into it, you can send follow-up invitations, because of course that's what the professional organizations would do. So students who didn't show up the first time, you do get some more who will show up after a second invitation. It's a great way to also educate just the student body in general. That invitation, hey, you were invited to be part of this survey. Here's why your response is important. You were randomly chosen. So that's one idea. Another idea, which we had a lot of fun with, was partnering with the AP Environmental Science class. And it could be an AP Government class. There's all sorts of other classes that require their students to run a study of some sort. So our environmental science teachers required their students to come up with an environmental initiative and implement it and measure the effects of it. And so it was that third part that we made ourselves available for to help students in their designs. So we got our PTO to fund some pizzas, and we got some parents to donate some snacks, and we had stats and snacks. And we just were there in the classroom during lunch periods. The environmental science kids dropped in and out and just chatted. It was just informal consultation sessions. And it was a really, really cool opportunity for the AP Stats kids to share their knowledge. A third option is working with the AP research students. You can do the same sort of a thing as Stats and Snacks, or you can make more of a long-term partnership since those AP research projects are so long. Of course, we are not doing the work for the AP research students. We are considered expert advisors. The AP research students can ask us questions about their designs, and we can answer them, but we certainly can't do any of their work for them. And so that works really well as a more long-term partnership if you can make that work. So the second part of what I wanted to talk to you about was rolling all of those ideas into a year-long course, a second year of AP Statistics. In doing that, we are able to spend the first 3 to 4 weeks of our school year looking at how the professional polling organizations run a good survey. What is proper wording of surveys? What is the proper question order? Does order matter? So these are certainly things we talk about in AP Statistics, but in a second year course, we can dive into those issues a lot deeper. A lot of the things that we get asked to consult on are surveys. So we spend some definite time at the beginning of the year talking about surveys. holidays. And we do all of those projects that I've mentioned. We work with the school newspaper, the AP Research Kids. We have done a survey for our school administration. They wanted to get a snapshot of what people thought about the different traditions that we have on campus. And so we wrote up a whole polling report for the school administration. It was very, very satisfying work, and the kids were really excited about it. Another facet of the course is that we do everything in R. We don't do anything in the graphing calculators anymore. We make our graphs in R. And so a chunk of our time is spent learning how to use not just base R, but also the packages in R are really cool. If you're interested in learning more about R, DataCamp is what I would recommend for you. We also, of course, learn more advanced statistical concepts, and as you can see those there. That's really most of our spring semester. So we spend the fall semester doing, learning how to do good polling, good survey design, learning how to navigate in R, reviewing AP statistics topics, and in the spring we do these things. We have tapped into so many different resources and many, many familiar names here on the screen. So if you're watching,
Darren, I believe you have to unmute.
Now, why would I have to do that? That doesn't make sense. Laura, we love you, sweetie, but you're killing me. Let's keep it to 5 minutes. Keep going, Laura.
your names here on the screen. So if you're watching, thank you for putting your work out there and allowing us to benefit from it. And if you've got any questions, I am happy to discuss any of this with you. My contact information is here. Thanks for watching.
As I said, the ever enthusiastic Laura Ringwood. All right, now our final presenter of the evening. This is by no means the least. This is Kevin DeVizia. Kevin comes from what I might describe as the greatest state in the union regarding AP Stat, Pennsylvania. And he, I might have been called out on that.
Yeah.
Anyway, Kevin has given many great best practices presentations in the past. None have been delivered in this format, obviously. And Kevin tells us he didn't count the number of retakes he did, but he wouldn't have been able to complete them without his wife. She would actually listen in and pretty frequently say, "That doesn't sound like you." At which point he'd slam his fist onto the table and restart the whole thing. And on a personal note, I personally, Kevin, I want you to know I stole your idea of free response Flapjack Fridays. And now me and my students, when we're actually in person-to-person settings, eat pancakes every Friday morning while doing free response questions before school. Fantastic idea. Without further ado, Kevin, take it away.
Happy holidays, folks. I'm Kevin DeVizia from Delaware Valley High School in Milford, Pennsylvania. I'd like to show you what I do around the winter holidays each year to help students build statistical reasoning and communication for success on the AP Statistics exam. I take actual released AP free response questions and the rubrics, and I translate their context into a holiday Christmas theme. I assign them to students to do over winter recess, and then when they come back in January, I collect their written work. Let me show you an example here. This problem is loosely based around the movie Elf. It's actually built around free response question number 1 from 2015 about 2 corporations and their salaries they pay their employees. For my problem, the 2 corporations are 2 workshops, and the salaries are the elves' salaries that they get. I converted the problem and its scoring rubric. And with the collected student work, when we return, I run a training workshop in scoring this question, just like what we would be doing on day 1 of the reading when we're trained in our first scoring rubric. The fixed up context makes it harder to Google this problem. while retaining its compliance to AP standards. And the big deal is it's a whole lot of fun for the kids. Another problem I do comes from 2011's free response question number 5. It's a problem about an apartment building with 9 floors and no carpet.
Kevin calls it Santa Claus. Kevin, I love you, but this is cracking me up. This is a great one. I love it. You've got to see Kevin's pennies one from last year or the year before last. It was awesome. But this is great. I absolutely love it. I had to put on my whole Christmas shirt too. This is great, Kevin. Love you. Thanks for finishing us out. Get back to it, Bridget.
Okay there, Darren.
Version is themed around Santa Claus is coming to town. It's about Somber Town with 6 streets, some of them in compliance with the new law restricting toys and others not. The problem focused on writing about cluster sampling and stratified sampling, a real challenge for my students, certainly at that point of the year. Again, students are trained in applying the rubric to student work, learning how to communicate the important ideas of sampling. Many students have told me that this activity was very useful in helping them think and write for their AP exam, and many have told me it was fun too. And at the end, with the scores that they get, here we go. Hang on. With the scores that they get, there we go. They learn to basically how these would map into scores that fit DV standards. On the AP exam, for instance, 50% of the points typically gets you a 3, the rough equivalent of a C grade, let's say, in Delaware Valley. We'll call it a 70. 70% of the points typically gets you a 5 on the AP test. Call it a 90 in Delaware Valley. And when we call 100% of the points a 100 in DV, I show them this curve, this function that maps hypothetical AP points to DV grades. So the students learn that they don't need to be perfect on an AP exam to be considered very, very good in DV's AP statistics class. This whole activity just makes this entire thing fun for the kids as they're doing it, and it's all worthwhile stuff for the kids to be able to do. It makes them more focused. It makes the class more fun. The files will all be provided for you, and I hope it's something you can use. Happy holidays, folks.
Bridget, are you going to come back to the 3 of us now?
Well, I've got a couple of things that I wanted to
Please.
throw in there. So I did not make my own presentation, but for those of you that are interested in the way this was done, Nearpod is a phenomenal online learning tool that you can use. There are free accounts. There are also paid accounts or district accounts through your school district. But it's turned into a lifesaver with this whole virtual learning transition that we've all had to go through. And so recommend that you check that out if you are curious. Also, everything that you've seen today is going to be posted on Bob Lashelle's website. That includes any of the documents that presenters had. The stream link will also be posted there, as well as the actual presentation from Nearpod. All right. I'll do that. Do you want to go ahead and just do the video at the very, very end?
Yeah, I think that'd be a great way to do the very, very end. I thought right now, Darren and Bridget, if you want to give any last minute thoughts, it'd be a great chance to do that.
Again, just appreciate everybody volunteering their ideas. As Doug has mentioned, this takes a lot to do. You get really nervous. We were talking beforehand. We're just a little sweaty before even going live. But thanks again. I know I'm going to absolutely steal a lot of good ideas today that I'll use throughout my classroom. Thanks again to everybody who volunteered their time, and a big thanks to Doug and especially to Bridget for getting us going today.
And thank you to Darren for all the laughs. I think that's one of the things that we all miss a lot about the AP reading is just your big belly laugh. So
I miss you guys too. I miss you guys too.
You're gonna get me all misty now. All right, Bridget, you want to cut us to the outro?
Yep, here we go.
In a world where Kansas City is the vacation destination of choice, a world where placebo eye drops make excellent rose fertilizer, a world where guacamole is at risk of disease, in a world where you're not quite sure what to use to heal your skin condition. This is the world where you always get along with your table partner, even if they make it known you're doing it all wrong. This is AP Statistics. We will find your bad graphs, and we will make fun of you.